The black hole at the center of our galaxy was supposed to be quiet. Not dead, not harmless, quiet. For decades, astronomers knew it was there. A dark object 4 million times the mass of the Sun, sitting roughly 26,000 light-years away, hidden behind dust, stars, gas, and the crowded heart of the Milky Way. We called it Sagittarius A star, A star, the black hole at home. Compared with the monsters in other galaxies, it looked almost sleepy. No enormous jet, no blazing quasar, no galaxy-shaking outburst, just a faint, compact object at the center of everything we live inside. And then, after nearly 50 years of searching, astronomers found the wind, not around some distant galaxy billions of light-years away, not around a cosmic monster in the early universe. From ours. From the black hole at the center of the Milky Way. That should change the way we imagine our galaxy, because the center of the Milky Way is not silent. It is breathing. When I was younger, I used to look at the Milky Way as if it were a peaceful river of stars. On clear nights, far from city lights, it looked soft, almost gentle, a pale band across the sky. It did not feel like something with a monster at its center. It felt like home. But astronomy has a way of ruining comforting images. The Milky Way is not just a river of stars. It is a rotating structure of gas, dust, dark matter, stellar ruins, magnetic fields and violence. And at the center of it all sits a black hole. The strange part is that our black hole has always been unusually quiet. In other galaxies, supermassive black holes can become active galactic nuclei. They feed on gas. They heat surrounding material to extreme temperatures. They blast jets across thousands of light-years. They reshape their host galaxies. Some shine so brightly they can outglow every star around them. A star does not do that. At least, not right now. It eats very little. It glows weakly. It flares sometimes in X-rays and infrared, but compared with the great active black holes of the universe, it is almost modest. For a long time, that quietness created a problem. Physics suggested that even a relatively quiet black hole should push material outward. Not always as a violent jet, sometimes as a wind. A flow of hot gas and energy moving away from the black hole, sculpting the surrounding environment. Astronomers had seen these winds around other supermassive black holes. They had models for them. They expected them. But in our own galaxy, the evidence remained frustratingly difficult to prove. The center of the Milky Way is messy. It is crowded. It is dusty. It is full of stars, gas clouds, magnetic structures, old explosions, and overlapping signals. Finding a faint black hole wind in that environment is like trying to hear one person exhale inside a stadium. For 50 years, scientists suspected something was there, but suspicion is not discovery. Then ALMA and Chandra helped reveal the shape of the breath. ALMA, the Atacama Large Millimeter Submillimeter Array, can map cold molecular gas with extraordinary detail. Chandra can see hot X-ray emitting material. Together, they gave astronomers a new way to look at the region around A star. And what they found was a cone-shaped cavity, a hollowed-out structure near the black hole, a region filled with hot ionized gas, a shape that looked as if something had pushed material away from the center. Not an explosion, not a catastrophic blast, more like a steady outflow, a wind. The phrase sounds almost gentle, black hole wind, but do not let the word fool you. This is not air moving through trees. This is plasma, radiation, gravity, and magnetic fields interacting around one of the most extreme objects in the galaxy. A black hole does not need to be devouring everything in sight to influence its surroundings. Even when it appears quiet, it can still push back. That is the first important lesson. Black holes are not only mouths, they are engines. For a long time, popular imagination treated black holes as cosmic drains. Things fall in, nothing comes out. End of story. But real black holes are more complicated. Most of the material approaching a black hole does not simply drop straight through the event horizon. It swirls, it heats, it collides. It forms an accretion flow. Magnetic fields twist through it. Pressure builds. Some material is pulled inward. Some is launched outward. The black hole feeds, but it also rejects. That rejection matters. Because black holes can regulate galaxies, they can heat gas that might otherwise cool and form stars. They can blow material out of galactic centers. They can slow star formation. They can shape the growth of the very galaxies that host them. This is called feedback. It is one of the most important ideas in modern astrophysics. And it is also one of the strangest. A region smaller than a solar system can influence structures thousands of light years across. The center whispers, the galaxy responds. A star is not a quasar. Its wind is not destroying the Milky Way. It is not a threat to Earth. We are far too distant for that. But the discovery matters because it shows that even a sleeping black hole may not truly be asleep. It may be in a quiet phase, a low feeding phase, a gentle phase, but still active, still shaping, still breathing. The old picture was simple. Active black holes shape galaxies. Quiet black holes sit there. This discovery makes that line blurrier. Quiet does not mean irrelevant. And that is a much more interesting universe. There is another reason this discovery matters. It gives us a local laboratory. When astronomers study active black holes in distant galaxies, they often see the big picture. The jet, the glow, the galaxy-wide disturbance. But distance hides detail. Sagittarius A star is different. It is our closest supermassive black hole. Close enough that we can study individual stars orbiting around it. Close enough that the Event Horizon Telescope could image its shadow. Close enough that we can measure flares, gas structures, and now possibly wind. It is not the brightest black hole, but it may be one of the most valuable, because it lets us study how black holes behave when they are not performing for the whole universe. Not every black hole is a cosmic lighthouse. Some are quiet machines, and quiet machines may be the most common kind. That is what makes Sagittarius A star important. It may be showing us the normal life of a supermassive black hole, not the dramatic phase, the everyday phase, the breathing phase. A black hole does not have to roar to matter. It can whisper for 20,000 years and carve a cavity in space. That sentence is what stays with me. A whisper that lasts long enough becomes architecture. But we should be careful. This does not mean Sagittarius A star has suddenly awakened into danger. It does not mean Earth is at risk. It does not mean the Milky Way is about to be torn apart. The wind appears mild compared with the violent outflows seen in more active galaxies. Scientists are still studying its exact size, age, and behavior. There are always uncertainties. The shape of the cavity, the history of gas near the galactic center, the possible role of nearby stars, the way hot and cold material interact. Science rarely gives us one clean sentence and stops, but the larger message is clear. The center of our galaxy is not passive, and maybe it never was. The Milky Way has a history we are still learning to read. There may have been times when Sagittarius A star was more active, times when it fed more aggressively, times when it produced stronger outflows. Some structures above and below the Milky Way's disk may be echoes of past activity. The galaxy we see now is not a still object. It is a record of events, old explosions, old winds, old feeding episodes, old violence softened by time. When we look at the Milky Way, we are not just seeing a home, we are seeing a fossil that still moves. That is what makes this discovery feel larger than a technical result. It changes the emotional meaning of the sky. The bright band of the Milky Way no longer feels like a static background. It feels like a living system, a galaxy with circulation, with pressure, with hidden weather, with a black hole at its heart, gently exhaling into the dark. And maybe that is the most unsettling part. The universe does not need to be loud to be active. A silent-looking galaxy can have a wind. A faint black hole can reshape its neighborhood. A peaceful night sky can hide a machine that has been working for longer than human civilization has existed. When I think about Sagittarius A star now, I do not picture a monster waiting to swallow us. That image is too simple. I picture something stranger. A dark engine in the center of the galaxy, mostly quiet, mostly hidden, but never completely still. Taking in material. Throwing some of it back, breathing slowly enough that only patient instruments can notice. This is what astronomy keeps teaching us. Our first impression of the universe is almost always wrong. The stars are not fixed. The empty space is not empty. The quiet black hole is not quiet. The home galaxy is not as calm as it looks. And every time we build better instruments, the universe becomes less like a picture and more like a process. So here is the question I want to leave with you. Which is more terrifying? A black hole that devours everything violently, or one that quietly shapes an entire galaxy without anyone noticing for 50 years? Some people fear the dramatic monsters. The quasars, the jets, the bright cosmic engines, but I think the quieter version may be stranger, because it means the universe does not need spectacle to be powerful. It can change things slowly, patiently, almost invisibly, and maybe that is the real lesson from the center of the Milky Way. Our black hole was never truly asleep. We were just not listening closely enough to hear it breathe.